Here is a little mystery before we start. When engineers program the path of a roller coaster or the trajectory of a rocket, they don't draw it by hand. Hold that thought, because today it becomes mathematics. Welcome to Math Concepts Made Easy. Today is day 5, and our lesson is all about Introduction to Polynomials. Before we start, a quick recap. In our last lesson, day 4, we studied laws of exponents, all 6 laws with intuitive proof and examples. If any of that feels unclear, pause here and re-watch day 4 first, because today builds directly on it. By the end of this lesson, student can conceptually define a polynomial, identify its parts, and recognize what makes an expression not a polynomial. Grab a notebook, get comfortable, and let us begin. Before we touch any formulas, let me show you where this idea already lives in your everyday life. When engineers program the path of a roller coaster or the trajectory of a rocket, they don't draw it by hand. They write a mathematical equation that the computer translates into a smooth curve. The most reliable tools for building these curves are called polynomials. You have been using this idea all along. Today we simply give it a name and learn its rules. So what is really going on here? A polynomial is just a mathematical machine. You feed it a number, x, it runs that number through a sequence of powers, multiplies them by coefficients, adds them up, and spits out a result. The rules for building this machine are incredibly strict: no negative powers, no fractional powers. Just clean, whole number exponents. Keep that picture in your mind, because everything else in this lesson grows out of it. Now we are ready to say this precisely, the way mathematicians do. Here is our focus for today: definition, degree, coefficients, types. In symbols, we write it as p of x equals a series of terms where every exponent is a positive whole number. Every word of that definition matters, so read it slowly. You already know algebraic expressions, variables, constants, exponents. This definition simply builds on those familiar ideas. Here is the key formula for Introduction to Polynomials. The formula is p of x equals a series of terms where every exponent is a positive whole number. Watch how each part appears as I say it. Do not just memorize the symbols, make sure you understand what each one represents, because that is what the exam really tests. Let us put this to work with real examples, one step at a time. Let's break down, for x cubed, 7x plus 9. Terms, for x cubed, negative 7x, and 9, coefficients, for a negative 7. Degree, highest power 3. Notice how every line follows logically from the one before it. That habit, checking each step, is what makes your answers reliable. Now, a quick warning, because I see students lose marks on this every single year. Before I show you, think about what could possibly go wrong here. 3, 2, 1. Students often think anything with an x is a polynomial. Show 1 x, which is x to the power of negative 1, and square root of x, which is x caret 1 2. Explicitly cross these out in red. Exponents must be non-negative integers. Compare the wrong way and the right way on screen, and promise yourself you will never fall for this one. Time to try it yourself. Here is your practice question. Which of these are not polynomials? Pause the video now, or take a few seconds with me. 5, 4, 3, 2, 1. Okay, let us solve it together. 1, 5x squared plus 3x, which means polynomial. 2, 2 the square root of x plus 4, which means not a polynomial, fractional power. 3, x cubed plus 5 over x, which means not a polynomial, negative power. How did you do? If you slipped anywhere, rewind and watch that step again. That is exactly how strong students learn. Let us bring today's lesson together in one picture. At the center of everything sits Introduction to Polynomials. We explored definition, degree, coefficients, types. The one formula to remember is p of x equals a series of terms where every exponent is a positive whole number. Watch out for the common trap we discussed. And remember our goal: student can conceptually define a polynomial, identify its parts, and recognize what makes an expression not a polynomial. Next lesson, zeros of a polynomial, finding zeros, graph connection, meaning. New lessons every day on math concepts made easy. Thank you for learning with me. See you tomorrow.